Hello everyone. In this video, we will be solving next problem of the Blind 75 series, which is minimum window substring. The problem statement is given two strings s and t of lengths m and n respectively. Return the minimum window substring of s such that every character of every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. The question says that you will be given two strings s and t as a input, and you have to search a substring in s which contains all the characters of t, and you need to return that substring which is of minimum length and contains all the characters of t. Okay, so like what will be the brute force solution for this? As we discussed in the last video, we can just check out every possible substring of this S and check if it contains all the characters of T. So you can use a hash map or hash array to keep a track of all the characters that you are getting in your current substring. So using two nested loops in the time complexity of n square, you can easily solve this problem. Okay, so the optimal solution of this problem again uses the sliding window technique that we discussed again in the last video. So let's review that. So in the last video, we discussed this general technique for the sliding window. Uh, what we do? We start with the minimum size window, and we just keep on expanding a window until I reach a condition like from where I cannot extend my window anymore. So I will keep on extending a window until condition become false. When the condition become false, I will try to shrink the window. So I will be using the same technique over here again. So here what I will do, like I want all the characters of this T in my substring in S. So I will start with the minimum size substring, and I will keep on increasing its length until I reach a point where I will have all the characters of T. So if I have reached at a point where I have all the characters of T, so at that point I will try to shrink the window and try to minimize the length. Okay, so let's understand this approach more clearly with the help of code. So I will use a hash array. As you can see in the constraints over here, we are given that S and T contains only uppercase and lowercase English letters. So I will use a hash array of size 128 because it will cover the ASCII value of both uppercase and lowercase letters. So let's name this as frequency. So it will be of size 128, and initially the frequency will be 0. Now, whatever characters of T I want in my substring of S, so I will just increase their frequency. I will increase the frequency of those characters in this frequency array. So I is less than T dot size I plus plus. So I will increase the frequency of all the characters of T that I want in my substring. Okay, so after this loop, what will happen? All the characters of T, like here in this example one you can see I have A, B and C. So frequency of A, B and C will become 1, and frequency of all other remaining characters will be 0. Okay, so this positive frequency means that I want these characters in my substring. Okay, so along with this I will also store the count of the total characters that I need. So the total characters that I need in my substring, let's call this as count required, is equal to the size of this string T. Okay, now I can start my sliding window technique. So let's declare two pointers I and j. These two pointers will denote the starting and ending point of a substring that I'm currently considering. So initially both will be set to 0, and let's store the size of this string as in some variable. Okay, so as I need to minimize the length, and here you can see that I have to return the string itself. For example, like here the smallest size string was B, A and C, which contained all the characters of T. So I have to return, I don't have to only return the length, but I need to return the exact substring. So for doing that, I will also, like, along with the minimum length, I will store the starting point of that particular substring, which contains all the characters of t. So minimum length will be like, I will declare it initially as a maximum value, and I will keep on updating it when I will get the lesser value. And the starting point is initially, let's say, 0. Now I will start my sliding window technique. So while j is less than n, okay, so what will be the current character that I am considering? That will be s of j. Now, like, whenever I am including any particular character of s in my substring that I am considering, I will decrease its corresponding frequency in this frequency array. Because like here I increase when the the characters of t that I wanted in my substring, those would have positive frequency in this frequency array. So whenever I get any valid character, like each time when I'm including a character of s in that particular substring, so I will just decrease its corresponding frequency. So like so it like when each time when the frequency was greater than 0, and when I'm reducing that frequency, so it means I have got a valid character of t that I wanted in my substring. Okay, so if I will check initially before decreasing the frequency, I will check if the frequency of uh, let's say s of j. I don't want this variable. Let's remove this. If frequency of s of j, if it was greater than 0, it means this was the character, it has positive frequency. So positive frequency means this was the character of t, and I wanted this in my substring. So now I am going to like include this in my current substring. So I will say I have got a valid character, so I will do count required minus minus. So now I need, like, suppose initially if I wanted t characters, now I want t minus one more characters of this string t in my current substring. Okay, so that's why I have decreased the count over here. And after that, I will simply decrease the corresponding frequency in my frequency array. So frequency of s of j minus minus. Okay, so like this part is little tricky because whenever I'm considering a string, considering a particular character in my current substring, so at that point of time I'm decreasing the frequency. And before decreasing the frequency, if I'm checking, if its frequency was greater than 0, it means it was the character that I wanted in my substring. So I will just do count required minus minus. It was a valid character. Now I want less number of characters, and I will just decrease the corresponding frequency in my frequency array. Okay, so it may happen that as I'm decreasing the value of count required over here, so it may happen that I will reach a point where I will have all the characters of t in my current substring. So at that condition, my count required will be 0. So if count required has become 0, it means I have got all the valid characters in my I have got all the characters that I wanted in my current substring. So now I will try to shrink the window. So for shrinking the window, here I was decreasing the frequency of corresponding character that I was including in my current substring. Now for uh, shrinking the window, I will just increase their count. Okay, so before increasing their count, as here this is the point where I'm shrinking the window. So each time when I'm shrinking, as I want the minimum length, so I will keep on updating the minimum length if I get the lesser length. So I will check if the size of current window, that is j minus I plus 1, if it is less than the minimum length, so I will say minimum length will be now j minus I plus 1. And as I want to return the string itself, so I want the starting point of that particular substring. So I will say starting point is now equal to I. Okay, now I just need to shrink the window. And for shrinking the window, I will just increase the count of this particular character. So I will say frequency of s of I plus plus. So it may happen that after increasing the frequency of any character, like it may happen that the frequency of any character may become greater than 0 again. So if frequency of any character has become greater than 0 again, it means that that was this is the character that I wanted in my substring, and now I again want this character. I included this character earlier, but now I have removed this character from my current substring. So I want this character again. So I will check if frequency of s of I, if it if it became greater than 0 after increasing its value. So I will say I want one more characters. Okay, so I want this character again in my substring. Okay, and after that I will simply do I plus plus. Okay, and here what we need to do, like I have already like computed, I am already doing computation for minimum length over here. So here I just need to increase the j pointer. Okay, so this is the uh, technique for sliding window, and after this loop ends I will check for a condition that if it may happen that there is no substring in my s which contains all the characters of t. So in that case my minimum length will not be updated. So I will check if my minimum length is still equal to int max. So it means I didn't got any, like I didn't got any length substring in my s which contains all the characters of t. So in that case I will just return the empty string. Okay, otherwise I will return the substring s dot substar, which will start from this index st, you know and the length will be minimum length. Okay, let's try to run this code. Sorry, it will be semicolon. Okay guys, this code works fine for sample test cases. Let's try to submit this. And yes, it got accepted. Okay, now let's discuss the space and time complexity for this problem. So in this code I am iterating over this string t here, and the, in this while loop I will be iterating over this string s. So like I am iterating over strings t and s. So if m and n are the lengths of string s and t, so the time complexity will be big O of m plus n, and the extra space that I'm using over here is this hash array that is of size 128. So we are always using the hash array of fixed size that is of 128. It is not dependent upon the size of s and t. So the you can say space complexity is constant. So that is all for today's video. We'll meet in the next video. Bye bye.